So this is our rational graphing practice that was due this morning. If you guys go into the assignment on Canvas itself, I posted the answers, so they're there. Your quiz is going to be Friday, okay? I gave you guys a quiz review. We'll look over it in a second, but your quiz is on Friday. You'll be given a problem like this, and it'll say, what's the domain? Where do we look for domain? Cheat sheet. Yeah, you need to look in your brain because you won't have your cheat sheet. But you'll have specific questions. It'll say one that'll say, find the x-intercepts of the zeros. That's where we factor the numerator. There'll be one that say, tell me the slant asymptote, the vertical asymptote. So you have to find the specific things. Then the last question will be like one of these that says, tell me everything and graph it. So we're going to go through these two. And then we'll play our little game. But if I asked you guys, and you should, if you don't know it yet, put that cheat sheet right next to you. If I ask you guys, what is the domain? First of all, domain and what go hand in hand? Yes, good. Vertical asymptotes and domain. So we're going to take our denominator, because our domain and vertical asymptotes deal with the denominator, and we set that not equal to 0, right? So when we move this over, x squared cannot be 9. We take the square root. X cannot be what two numbers? Plus or minus 3. All right, I cannot impress upon you enough the importance of plus or minus, of x equals versus y equals. You will be, points will be taken off if you don't have x or y. If you don't write things in interval notation, if you don't use ordered pairs for your intercepts. So just make sure you guys are paying attention to these things. So if you're going to state the domain for this function, what is the domain? It can be anything in the entire world except for positive and negative 3. So how do I write that? Negative infinity to negative 3, union, negative 3 to 3, union, 3 to infinity. Perfect. Good. There's your domain. So then I said, well, what are the vertical asymptotes? You guys would tell me about my vertical asymptotes are where? At x equals plus or minus 3. You can write x equals 3, x equals negative 3. You can write plus or minus. I don't care, but you have to have x equals. Everybody got that? All right, how do we find horizontal asymptotes? N and D, good. I was going to ask Carolina, but she's not here. N and D, we compare the numerator degree to the denominator degree. So the numerator degree is 2. The denominator degree is 2. So those are equal to each other. When the numerator and denominator degree are equal to each other, how do you find the, what is it? Tell me. Good. Leading coefficient of the numerator over the leading coefficient of the denominator. So it's at y equals 1. Y equals. Our horizontal asymptotes are at y equals. Everybody with me? Mm-hmm. Slant asymptote. How do we find our slant asymptote? Long division. It should be in y equals mx plus b. If you have a slant asymptote, it's going to be the equation of a line. So if we do our long division, x squared minus 9 into x squared minus 4. Guys, first term into first term. X squared goes into x squared how many times? Once. If you were to write that as an equation of a line, this would say y equals 1. Is that a slanted line? No, y equals 1 is our horizontal asymptote. So your slant asymptote would be none. So on your... The reason I'm not writing down at the bottom, I will in a second, but I just want to go back and up and down, make you guys dizzy. On your quiz, the last question, I actually wrote out like lines for domain, X-intercept, Y-intercept. So you guys know exactly what to answer, and it's all right there on a list for you. So make it a little easier. So now if we're going to talk about X and Y intercepts.
Wait.
Yep. Y equals 1 is your horizontal asymptote. A slant asymptote will be a slanted line like 2x plus 3. Negative x minus 5.
That's have an x value in it, right? Or no, not necessarily.
It has to have an x in it, yeah. Yeah.
So if it doesn't, then none.
Another way you can tell if there's a slant asymptote just by looking, guys. Hold on, let me record this so you can hear it. Oh, I'd never stopped recording, my bad. There we go. A slant asymptote, the numerator degree has to be bigger than the denominator. Because think of it. If it was x cubed over x squared, you would say x squared goes into x cubed how many times? X, 1x, right? So if the numerator and the denominator degree are the same, you won't have a slant. That's just a little thing to look at. But if you guys are going to find X-intercepts, look at your cheat sheet. How do you find the X-intercept? What equal to 0? Numerator, x squared minus 4 equals 0. Now you can do two things here. You can factor it, x plus 2x minus 2, and then solve. Or you can just solve. You could just move x squared equals 4, take the square root, and where does x cross here? At plus and minus 2. But I want it written as an ordered pair. So how would you write these two as ordered pairs?
2, 0, -2.
Perfect. 2, 0. Good, Julia. And negative 2, 0. I know, you're doing good. All right, look at the next one. How about y? How do you find the y-intercepts? You're going to plug in 0, f of 0. So 0 squared minus 4 over 0 squared minus 9. What's negative 4 over negative 9? Just 4 over 9, right?
Yeah.
Write that as a point. 0, comma, 4 over 9. Good. And then the last thing we're going to look for are holes. How do you find holes?
Plug in numbers and then solve.
Factor numerator. Factor the denominator. So I have x minus 2, x plus 2. X minus 3, x plus 3. Correct? Does anything cancel out? Is anything exactly the same on top and bottom? So what are your holes? There are none. No holes.
So you wouldn't necessarily. Okay.
Let's go through. The first thing we should plot. You should always plot your asymptotes and your intercepts. So where are my two vertical asymptotes? At positive 3 and negative 3. So x equals, so positive 3 is here. Remember, they're not solid lines. They're dotted lines. So I have asymptote here. I got another one over here. Agreed? All right. And then where is my horizontal asymptote? At 1. Okay. All right. And then let's plot our intercepts, please. Where are my x-intercepts? Positive, negative 2. And then my y-intercept was at 4/9. So that's in between 0 and 1, right? You guys agree with me? Now, when we have our vertical asymptotes, when I have two of them, there's going to be boomerangs on the side and then something in that middle section. It's either going to be a parabola or a cubic looking thing. And that's when we plug in points to see what it's going to be. So on your quiz, I'm going to tell you guys, you have to have at least 5 extra points. You got to have 2 to the left of the vertical asymptote. You need to have at least 2 in the middle. And then you have to have at least 2 on the other side to kind of give yourself a picture. What do you notice happened when you plotted your 2 x-intercepts and your y-intercept? It's a parabola. See how they're all in the same region? So this is going to create a parabola right here. You guys can just go ahead and draw that. Now, some of you turned in some work that was, we'll just call it subpar. Some of you did a really good job on your graphing. Some of you, it looked like Valentina and Reagan did it all by themselves. Right? My 4-year-old twins. Your graph, guys, has to be, it doesn't have to be perfect, like when we plug in points and find the general area of where our boomerangs are, but you cannot be sloppy. You've got to make sure that I know that you know where the intercepts are, that I know where your asymptotes are, all that stuff. So let's pick 2 points, like Gabby was telling us a second ago. Let's pick 2 points over there in the green section. On the x-axis, pick 2 points in the green section. What do you want to do? Negative 10 and negative 5. Perfect. So I'm gonna plug in negative 10 and see what I get out about, and negative 5 and see what I get out about. Just get an area. What is it's x squared minus 4, right? Over x squared minus 9. Okay. So negative 10 squared minus 4 over negative 10 squared minus 9. Well, negative 10 squared is 100, right? 100 minus 4 is what? 96. Good. 10 squared, again, 100 minus 9 is what? 91. How many times can 91 go into 96? 1 and a bit, right? So when I write 1-ish, the thing that's so important about that ish is when I go to -10 and I go up to 1, is this point above or below that horizontal asymptote? It's a little bit above. That's very important. So now we're going to do the same thing with -5 because we're just getting a general area of where our boomerang exists. So I have -5 squared minus 4 and -5 squared minus 9. So 25 minus 4 is 21. 25 minus 9 is 16. So 16 goes into 21 about how many times? 1-ish. What is really important about that 1-ish? It's a little bit above 1. So do you guys see where your boomerang is going to exist? In the top region or the bottom region? In the top, right? You're going to just kind of draw your picture so it kind of hugs along the asymptotes, goes through those points. Questions? Yes, ma'am.
How do you know, like,
We already know where the middle one is, right? Just because of we lucked out with how our intercepts worked. So let's pick something over here. Because just because it's in the top left here doesn't mean it's going to be in the top right on the other side. Sometimes it works out that way and sometimes not. So let's pick 2 points in the red section. I need 2 x values in the red section. What are we going to use?
4?
Okay, we can do 4 and 7. Perfect. You can use the same, yes, Audrey. So if I had 4 squared, what is it again? It's x squared minus 4, right? So 4 squared minus 4 over 4 squared minus 9, all right? 4 squared is 16 minus 4 gives me 12. And then 16 minus 9 gives me what? 7. All right, 7 goes into 12, about how much? 1-ish. It's a little bit above 1, right? So at 4, I'm going to go up a little bit. Do I already know now where my boomerang is going to exist? Is it going to be in the top right or the bottom left? Is that in the top right or is that in the bottom right? I'm sorry. I mean left. I don't know why I said that. It's going to be in the top. But let's put in 7. So I have 7 squared minus 4 over 7 squared minus 9. So 49 minus 4 is 45. And then 49 minus 9 is, all right, 40 goes into 45. About how much? 1 and a little bit, right? 1-ish. So at 5, 6, 7, I'm up here. So do you guys see where your boomerang is going to exist? In this top right portion up here, correct? And then you're just going to draw your boomerang so it hugs your asymptotes. Gets close to them but doesn't touch. You want it to just kind of hug those asymptotes. So your graph looks something like this. On your quiz, your graph should look very similar to something like this. It should have some order to it. You should see where the X and Y intercepts are. You should see where the vertical and horizontal asymptotes are, that sort of thing. Questions? This is different than what's on your paper. Yes, ma'am. Sure. This is different than what's on your paper, so just follow along with me as we go through this. But again, let's talk about the domain and the vertical asymptotes. I'll write everything down here. Domain and vertical asymptotes. Domain go hand in hand with vertical asymptotes. How do we find the domain or vertical asymptotes? Denominator equal to 0. X squared plus 4x minus 12 cannot be 0. So I factor this. What are the factors of -12 that multiply to give me -12 but add to give me 4? Good. X plus 6 and x minus 2. So x cannot be -6 and x cannot be +2. So my domain, if I wrote my domain, what would that look like? Everything in the world but -6 and +2. So -infinity to -6, right? Union, -6 to 2, union 2 to infinity. And then my vertical asymptotes are where? At x equals -6 and x equals +2. Good. Horizontal asymptotes. How do we find horizontal asymptotes? You compare the numerator degree to the denominator. Well, the degree of the numerator is 2. Degree of the denominator is 2, so they're equal to each other. So it's going to be y equals 1 over 1. So your horizontal asymptote is at y equals 1. Y equals 1. Very important, guys, that we have our x equals and our y equals, right? Okay, so slant asymptote. Do I have a slant asymptote? Nope. How do you find slant asymptote? Long division. So if I say x squared plus 4x minus 12 into x squared minus 16. Well, first term into first term is what? 1. That's just going to be the line y equals 1, which is our horizontal asymptote. For your slant asymptote, there is not one. Your answer is none. So in this little box or on the line on your quiz, you would write none. Yep. How do we find X-intercepts? Set the numerator equal to 0. So X-intercept, I say x squared minus 16 equals 0. X squared equals 16. So X-intercepts are at plus and minus what? 4. So I would write that on my line or in this box over here. How do I write plus or minus 4? 4 comma 0 and negative 4 comma 0. X-intercept has 0 as your y value. If we're going to find the y, how do we find y? Plug in 0. Good. So I have f of 0 equals 0 squared minus 16 over 0 squared plus 4 times 0 minus 12, right? So this cancels, this cancels. You have negative 16 over negative 12 gives me 16 over 12, which is 4 over 3? Yes? Okay. So then I would write that my y-intercept is at 0 comma 4 over 3. Agreed? All right, and last thing we need to look for are holes. So how do you find holes again? Factor the numerator and the denominator. So this would be x minus 4, x plus 4 over, what was it, x plus 6, x minus 2? Right? Does anything exactly the same? That'll cancel out. So you would say no holes or none. But on your paper, you're going to have a line and you have to write no holes, none, you know, whatever. Slant asymptote, if there isn't one, write none. But you have to have answers for every single line. Everybody see that? All right, so let's go through the process here of graphing. I have 2 vertical asymptote. One is at negative 6 and one is at positive 2. So here's one of them over here at negative 6. Correct? And I got one over here at positive 2. You guys are welcome to use my color pencils when you come in. Where is my horizontal asymptote? At y equals 1. All right, now let's plot our intercepts. Where is my x-intercepts? Where are my x-intercepts, I should say, I'm sorry. And where is my y-intercept? 4, 0, so here. Negative 4, so over here. And then where's the y-intercept at? 4/3. Where's 4/3 on the y-axis? It's a little bit above. It's up here, right? So how is this a little bit different? Are all 3 of those points in the same region? No. Can you just go like this and say, oh, there's my parabola? No. You absolutely cannot cross the vertical asymptotes with your graph. So that's just because you can draw a parabola, don't. Those 3 points are not in the same region. Do you guys see that? I have 3 different regions in this graph. I have one right here. I have here. And I have here. So we need to plot some points. So let's pick 2 points in that red region along the x axis that are in between negative 10 and negative 6. What 2 points you want to use?
Negative 6 and negative 9.
Can't use 6 because it's the asymptote. So how about 7? And then negative 9, that's fine. Just don't use points that are right next to each other. So my original function, so I don't mess up, let me rewrite it just to make sure I see it. X squared plus 4x minus 12. So when I plug in negative 7, I have negative 7 squared minus 16 over negative 7 squared plus 4 times negative 7 minus 12. What's negative 7 squared? 49. And 49 minus 16 is 33. So on the bottom, I have negative 7 squared, 49, right? 49 minus 28 minus 12. What's 49 minus 28? 21 minus 12 is 9. How many times does 9 about go into 33? Between 3 and 4, right? So 3-ish, a little bit above 3, that's fine. So I know I'm going to go over here to negative 7, and I'm going to go up 1, 2, 3, and a bit. Does everybody see the general area that our boomerang is probably going to be in, that top left region? So let's just plug in, what do we say? Negative 9? Okay, let's try negative 9. Negative 9 squared minus 16 over negative 9 squared plus 4 times negative 9 minus 12. What's negative 9 squared? 81. And 81 minus 16 is 81 minus 16. Come on. How much? 65? Okay. And then 81 minus 36 minus 12. What's 81 minus 36? Minus 12. 32. All right. 32. 33. Okay. 33 goes into 65. About how many times? Almost 2. Really close to 2, right? So we'll say 2-ish. It's almost 2. Well, the big thing is to understand that it's going to be above what? It's going to be above that 1. So do you see that your boomerang is going to be right here? I get in this middle section. I already have 2 points. What would be the best point to pick, you think? The where and where? Tell me, what X should I pick? You want to pick something over here? Okay. You could do that and get some general shape. I'm going to pick positive 1. Why am I going to pick positive 1, you think? To know if it curves up or down. Do you guys notice how this point is below? This point is below the horizontal asymptote, and this point is above it, right? So I'm going to pick 1. You could pick a different point. You'll still get the same answer. But I'm going to pick 1 just to see what happens if that point goes higher or if it goes lower. So if I plug in 1, all right, I'm going to plug in 1 and see what I get out. And it's 1 squared minus 16 over 1 squared plus 4 times 1 minus 12, right? Well, what's 1 squared? Minus 16, so it gives me negative 15. And then I have 1 squared plus 4 is 5. Minus 12 is what? Negative 7. 2 negatives give me a positive. So 7 goes into 15 about how many times? 2 and a bit, right? 2-ish. So this point, when I plug in 1, is right here. Do you see the shape that this is going to make in the middle here? Is it a parabola? No. It's like a curvy little snake thing, all right? So you guys have to pick. I missed that point. But do you notice how this shape of the graph is different than the last one? We don't have a parabola. You can't just connect 3 points and say, oh, it's going to be a parabola. Kaylee, your best bet when you're trying to find stuff in the middle is you want to try a point that's really close to the left vertical asymptote and then pick a point that's close to the right vertical asymptote. So you can see what's going on close to the asymptotes. Pick one to the left. So what would be close to your left vertical asymptote? Like -5. What would be closest to your right vertical asymptote? 1. Just pick something close so you can see what's going on.
So you always have to plug the X-Intercepts first.
Yeah,
right?
it gives you, it kind of helps you out a little bit. Now look, where do you guys notice that the intercept is in this last region? Is it above or below the horizontal asymptote? It's below it. Now you can go through horizontal asymptotes. You cannot go through vertical ones, but you can go through horizontal ones. So we already have 1 point there. Let's pick another point on the x-axis. Which one do you want to plug in? 9. Let's plug in 9. Let's see what happens. When I plug in 9, let's see what I get out. So I have 9 squared minus, what is it, 16? Yes? Okay, so on the bottom here, we have 9 squared plus 4 times 9, right? Minus 12. Okay, so 81 minus 16, you guys told me was 65. And then 81 plus 36 minus 12. Well, what's 81 and 36? 117, right? Minus 12, 105. How many times can 105 go into 65? Less than 1, right? So when I come out here to 9, my point, no matter what it is, it's here between 0 and 1, correct? So where does this boomerang exist? Above the horizontal asymptote or below it? Below it. It's down here. That's why it's so important to check. That last problem we did, if you guys noticed, one was in the top left, the other one was in the top right. You can't just assume that they're always in the same spot. You got to check. You got to go through and check. And that's what takes the longest with this. It's the most annoying, I know.
Ones on the ends always going to be boomerangs. So if for some reason my dog crossed the line, it would be wrong.
No.
Messed up somewhere.
Well, in this case, yes. But you can, like, not in this problem, but you could have gotten where it went like this, and then your boomerang just kind of went like a little up like that. Because there are instances where you can cross the horizontal asymptote, but not the vertical ones. You'll get real close to them and never touch them. But sometimes it does, like, look at right here. This crosses the horizontal asymptote, right? It goes through it. That can happen, but it's not the other way around. All right, so on your quiz, you're going to have one of these where you got to do all the stuff. So make sure you guys know how to do it, please. I'll upload this right now.